Hello, my name is Alan, and welcome to a basic tutorial on how to use some of the basic bench equipment in the ECE laboratory. In this video, I'll be going over how to use the function generator, the DC supply, as well as the oscilloscope, and as well as some tips and tricks on some general things that I've picked up going through this major as an undergrad. I will be doing this entirely off script, so bear with me a little bit, but hopefully you might find this a little bit useful as you may have already had some experience in working with this stuff, and maybe I can point some things out to you that might be helpful, or if you're a complete beginner, totally fine. I'm going to try to make it accessible for everybody as much as I can. Alright, so let's start off with probably the first thing that everybody sees coming into an ECE lab class is the breadboard. So you see on here I already have a basic 741 operational amplifier already plugged into the board. But before I get ahead of myself, I'm going to go over kind of just how the basic connections on this thing work. Essentially, it's pretty basic. So you'll see these red and blue lines here, and if the camera can focus in on it a little bit, you can see there's a plus and a minus. These are the vertical connections on the breadboard. Now, these plus and minuses don't mean or don't indicate that you absolutely have to put ground on the blue line or the negative voltage or negative whatever on the blue line. Likewise with the red line, doesn't indicate that you need to have positive voltage or otherwise on this vertical line. It's just for your reference. Now, before I move on, you need to be careful because sometimes in this lab you'll encounter breadboards that look like this. And see if you can spot the difference. You'll notice that on this one there is no continuous line on the vertical part of the breadboard. There's a break right here. Now that splits this vertical line up into two sections. So this entire line is not connected to this entire line. It's just something for you to be aware of in case you try to put your signal into here and then you're trying to pull it from this other end and you're confused as to why there's no connection. That's probably why. So moving on. When you are putting up, first of all, with regards to chips, if you're putting an integrated circuit onto the board, you have to connect it like this, where you have pins going into the bottom part. Over this separation, there is no connection across this separation to the top of the separation I was just talking about, right? That's because, as I just mentioned, there is no connection between these two parts, right? This is pretty basic stuff, but I've seen it here and there where people aren't entirely sure about how these horizontal connections work. And I'll go ahead and flip this real quick. You'll see there are some numbers. Which again is really just more for your reference. Completely up to you how you use these numbers. There's no real set rule about it. I like to start my chips on these even numbers, so it's pretty easy to count. Pin 1, 2, 3, 4, 5, 6, 7, 8. And now the only thing you really need to note about this main body of the breadboard is that it consists of all these horizontal connections. Now before, with the vertical lines, where you had all of these on the bottom right above the red are all connected to each other, and all the blue are all connected to each other. Each row from A, B, C, D, and E on one is all connected, right? So if I were to put a wire into here and then another one into there, this is a connection that doesn't really do anything. Because I am just connecting it to itself, right? However, let's say that I wanted to connect a wire from here to this other side. This is a separate connection because, again, due to this separation, they are not connected. And again, as you might have figured out by now, if I were to put the wire into here, into the row below 20, which you can see right there is 20, then you can see that these are two separate connections, right? Connecting from this top of the wire to the bottom part of the wire. Now, the last thing that we need to talk about for as far as the basic breadboard goes is the breadboard holder. These knobs with these twisty bits on them are all very helpful. You'll notice that they're made of metal, right? They're used to help you make connections from your input devices to your breadboard. Now, there's a couple different ways of using them. Let's say this red wire right here is our AC output from our function generator, which we'll talk about in a little bit. Okay? Rather than sticking an alligator clip on and just kind of doing this, right, where it's coming from the, yes, it's coming from the AC function generator, and it's attached by this wire, by this clip to the wire to the board. This is a little bit messy, and my wire is falling out here, but that's not super important right now. Oh, there we go, got it. Okay, this is messy because sure, not too much harm is being done with just this single cable and this single clip. However, if you start doing this for all of your inputs, then all of a sudden your workspace is going to start looking like this. And then let's pretend this is a ground. My ground is making contact with my AC function generator, and all of a sudden you have a direct connection to ground, and you're probably going to break something and have to go talk to the ECE technicians as to why you just destroyed some lab equipment. So, in order to prevent this, we're going to use these things that are surrounding the breadboard to help us make these connections in a safer way that's less likely to cause us to have any bad connections. Right? So, there's a couple ways of doing this. Probably the most correct method of utilizing these things is to take your input, get some wires out here, clean up our station a little bit. Take an input, plug it into this, this. What are we going to call them? We're going to call them cable holders. Plug it into the cable holder on the breadboard holder. Then take your wire. Angle this so you can see a little bit better. Take your wire, and you want to spin this until it clamps down on the wire. Everything kind of on the inside of this this plastic cable holder. It's not really working for me very well. It's a little bit finicky sometimes. There we go. You'll see it's kind of clamped in there. All of that is metal, so it's going to conduct whatever voltage or current you have going through here into this wire, into your breadboard. And this is pretty neat because this plastic and all this is protecting you from any kind of loose cables or otherwise that might be strewn about, which hopefully you're trying to keep keep a handle on, although sometimes things can get a little bit messy as you start to get further and further into some labs. Now, my favorite way, my personal favorite way of using these cable holders is to take your wire, put it into the part. Ooh, my cable fell out, but we'll just pretend it, or my wire fell out, but we'll pretend it's still connected here. My favorite way of working with these is to take the other end of your wire that's not into the breadboard and put it directly into where the cable is going to go, into the cable holder. Now you plug this in and you can jam it in there. Might take a little bit of effort, but it's fine, you're not hurting anything. And look at that. You've got your input connected to the breadboard holder. This wire is firmly in there. It's not going anywhere. It's also protected from any kind of loose connection. Now you can connect this input to your breadboard. So again, as you're working on your projects in here, be very careful to avoid any bad connections. It might be, I'll just reiterate this again because this has happened a bunch of times. Has happened at least once to myself, which is why I'm encouraging you to do this. You have to be very careful about getting into the bad habit of overusing alligator clips on your inputs. For the multimeter, it's not as much of a bad thing. For the oscilloscope, if you're using it as a probe, you're not likely to cause any damage using alligator clips for that. But definitely with your DC power supply and your AC power supply, you got to be extremely careful with where you have them on the table and what's making a connection to what. Yes, you won't really cause much of a problem if they're lying on the table themselves due to this rubber insulating mat, as well as the fact that the tables are made of wood. But you still may introduce noise into your system if that's if it's lying on the table and then connecting to your circuit, or like I said earlier, again, if you accidentally connect like a positive voltage to a negative voltage, then you blow up some equipment accidentally, right? So that has happened. It's going to keep happening, but only you can prevent that from happening if you practice good cable management and kind of utilize this tactic of using these cable holders. And now to kind of just wrap this up with a little illustration of a basic setup for using the breadboard here. You'll see that I have this set up with a negative voltage input right here into this cable holder, positive voltage right here into this other cable holder, and I put my ground into this cable holder. And you can see with this method of setting up your connections for your breadboard, there's very little opportunity for things to make bad connections here. And I'll zoom in a little bit so you can kind of just try to see a little bit better. Here you can see I've got my positive voltage going into the very top of my 741 here. This is just a basic difference amplifier. And I realized after I had started my recording just now that I had forgotten to put my AC voltages into my circuit here, which is required for a basic difference amplifier, which is what I have constructed here. But as you can see, I have my AC input 1, AC input 2. They're not making any bad connections with anything. Going in right here into my positive or my inverting and non-inverting terminals in my 741. And then I have ground right here all along this line. I have positive voltage all along this line, negative voltage all along this line, and hopefully you can see through this why this is a good practice to use for building circuits in here. Alright, next we're going to move on to looking at the AC and DC power supply, and then hopefully we can wrap it up with the oscilloscope.